We're going to take a quick few minutes to review rounding decimals. Pause for a moment so that you can copy the notes into your term notebook. If you're not sure of the page, look at your table of contents to find where the lesson is on rounding decimals. Then pause, copy, and hit play when you're ready to move on. So step 1 for rounding decimals is to underline the place to which you want to round. Step 2, look at the next digit to the right. And that digit's important because if it is anywhere from 0 to 4, so 0, 1, 2, 3, or 4, the underlined number is going to stay the same. If that digit to the right is 5, 6, 7, 8, or 9, then the underlined number is going to go up 1. Then we drop all the digits after the underlined digit. We don't make them zeros like we would with whole numbers. That's the difference between, what's one of the differences between rounding decimals and rounding whole numbers. So let's look at some examples. Looking at our chart, we're going to take this number 6 and 2,564 10,000ths, and we're going to round it to the nearest tenth, then to the nearest hundredth, then to the nearest thousandth, then to the nearest whole number. So in looking at that, if we want to round to the nearest tenth, we can see that the 2 is in the tenths spot, and I know that because if I use our decimal trick, the 2 is above the 0. So 6 and 2 tenths, is it going to stay that, or is it going to go up to 6 and 3 tenths? Well, we look at the 5. The 5 is between 5 and 9. It tells the 2 to go up to a 3. So this is going to round to 6 and 3 tenths. When we want to round to the nearest hundredth, we're going to put a 1 under the decimal, a 2 zeros to make the number hundredth, and then the 5 is over that last 0. So it's in the hundredths place. The 6 tells the 5 to go up, so we end up with 6 and 26 hundredths. When we want to round to the nearest thousandth, put a 1 under the decimal, a 0 under each place after it. So 6 is in the thousandths place. The 4 is not big enough to make the 6 go up. Now sometimes people get confused and say, but the 6 is between 5 and 9. It doesn't matter. It's the 4, it's the number after that we look at. So that tells the 6 to stay the same. 6 and 256 thousandths. And then to the nearest whole number, remember whole number means the part before the decimal. So right now that is 6. The 2 that's behind the decimal tells the 6 to stay the same. So this rounds to 6 wholes. Take a moment now to finish the rest of the chart, and then after you're done with that, play the rest of the video and check your answers. Okay, and here are the answers to the rest of those rounding problems. One that I want to check your answers, but one that I want to highlight specifically is if you look at this one right here. People often either get this wrong or leave off the 0, and the reason for that is because if we round to the nearest hundredth, that 9 is in the hundredth spot. A 7 tells it to go up. Well, a 9 would go up to a 10, but the problem is we can't put 2 digits in one spot, in one place value position. So we have to really look at this as 29 and say 29 goes up to 30. And yes, we do need to keep that 0 because we're rounding to the nearest hundredth. And if we don't keep that 0, then we only have digits out to the tenths. If we're rounding to the nearest hundredth, we have to have something in the hundredths spot. Make sure that you note at the bottom that if we're rounding to the nearest cent, that means to the nearest hundredth. Money is 2 places after the decimal. If we're rounding to the nearest dollar, that means we're rounding to the nearest whole number because dollars are the part that come before the decimal when we write money. Now we're going to take a look at comparing and ordering decimals, and this is, again, should be a review, but a couple things I want to highlight. Steps 1 and 2 are critical to doing this accurately. Step 1, line up the decimals. That's going to make it a lot easier to compare. Step 2, annex the zeros if you need to so that all of the numbers have the same number of places after the decimal. I'll explain that more in a moment. Step 3, compare the whole numbers. That means the part before the decimal. Step 4, compare the decimals. That means the part after the decimal. And then step 5, rewrite in order. So when we look at our first example, we line up the decimals. By the way, if you've not finished copying the notes, pause, copy the notes, and then move on to the example. So we're going to line up the decimals, which means to do this, where if I wanted to, I could write a line that goes through all of the decimals. Step 2, annex zeros. Now, some people want to go ahead and start comparing now, and they'll say, okay, well, the whole numbers are the same. They're all 9s. But when I look at the part after the decimal, These two are going to be equal because they're both 6's. And then I have 66 and then 76. But you can't do that. That's a little bit like playing a 3-against-1 basketball game. It's just not fair. So what we have to do is make it fair, make it a fair comparison by making all of the numbers have the same number of digits after the decimal. Now, annexing those zeros doesn't change the value of the numbers, but it does make them easier to compare. So now this becomes a lot easier. I look at the whole number part, they're all the same. So since those are all the same, I can't really, I can't do anything yet. I can't base a comparison on the whole numbers. So when I look at the decimal part of it, I want to go from least to greatest. So 60, then 76, then 600, then 660. And last but not least, let's take a moment to rewrite the numbers in order. So that's going to give me 9 and 600ths, 9 and 76 thousandths, 9 and 6/10ths, 9 and 66 hundredths. Let's look at one more example. So if I have these numbers, I want to put in order from greatest to least. Again, I'm going to line up the decimals, annex some zeros to help me do my comparing. All of them need to have the same number of places after the decimal. And then I'm going to be ready to compare in the whole number spot. And now when I look at these, notice again, I'm going greatest to least. Always pay attention to which way you're ordering. So from greatest to least, the 13 is definitely my least. It's going to come last. No matter what comes after the decimal, because the whole number is the smallest, that one's going to be last. So now look at the part after the decimal. Now remember, we've already decided this one's going to be last. So looking at the others from greatest to least, 200, then 23, and then 9. And we're ready to rewrite these numbers in order. So in order, I'm going to get 14 and 2/10ths, 14 and 23 thousandths, 14 and 9 thousandths, and then 13 and 95 hundredths. Let's look at a couple more that you can try on paper. Here's 2 sets. Try those. Pause while you try it, and then we'll check. All right, so here is your first one with your numbers rewritten in order. I want you to notice that for the whole number, let's see, for the whole number one, for the 9, we had to put a decimal right after the 9 because that's where the decimal goes in a whole number. It goes after the whole number. And then we ended up annexing 3 zeros to make all of those have the same number of spots. And then we annex zeros on some of the others as well. So in order, you would have 8 and 19 thousandths, 8 and 21 thousandths, 8 and 2/10ths, 9, 9 and 3 thousandths. And then for our last example, we were putting them in order from greatest to least. And we ended up getting 17 and 96 hundredths, 17 and 935 thousandths, 17 and 931 thousandths, and then 17 and 9/10ths. Please make sure